And hello. And Sam, you can hear me okay?
Yep, all clear.
Excellent. And thanks everyone for bearing with us while we had a minor technical issue at the start of the call. But welcome everyone to the latest edition of what's now known as the My DevSecOps virtual session. My DevSecOps is an inclusive community that educates and enables developers in application security. So coming up today, we have Sam Bellin from Author, who's going to be talking about authenticating your single page apps using JSON Web Tokens. And before we dive into the session, just a quick intro about myself for those of you and we're meeting for the first time. So my name is Oliver Byrne, and I'm a community manager here at Sneak. So working with my fellow human, Sam Hepburn, on the community team. And I'm here to help run the session smoothly, hopefully with no more technical issues, and also to coordinate any questions for Sam as they come in. And you can feel free to drop any questions into our live session channel. Myself, Sam, and Sam Hepburn are in that channel ready to pick up your questions as we go on. We'd love your feedback as we go through, so during this session, post session, so we can continue to improve the sessions that we bring to you. You can certainly find us on Twitter by searching for My DevSecOps and giving us a follow. And you can also join our Slack community if you're listening to this directly on YouTube or on our website. And you can find that link on mydevsecops.io. Our Slack community is actually the best place to interact with all of our speakers, to collect all of our post-session resources, slides, any links that we share from our speakers. We also have lots of fellow community members, so we're coming up to 1,000 members, which is fantastic. And then once you've joined the community, you can join our future sessions by joining the live sessions channel and asking any questions during any of our future sessions. Once the session is over, you can rewatch the session on our website. So again, if you're listening to this post session, you can listen to it on the website or directly to our YouTube channel. And just to let you know, the My DevSecOps is brought to you by Sneak. And our aim for this community is to create a vendor neutral space to share knowledge and best practices related to software security. So that's the intro for who we are. Now I'm going to hand it over to Sam Bellin, who's going to introduce himself and take us through the rest of this session. So Sam, over to you.
Let's go. Let me quickly share my screen so you can see the slides I prepared. Should be all good to go. Can you confirm that you can see my slides?
Yeah, I can see your slides. Great.
Perfect. So like I mentioned in the introduction, I'm going to be talking a bit about JSON Web Tokens and how to use them together with single page applications, because these kind of applications we've been building for a while, but they pose a certain set of problems when you're dealing with authentication and how to deal with them in a secure way. But let me quickly introduce myself. My name is Sam Bellin, and I'm a developer advocate engineer at Auth0. If you've never heard of Auth0 before, that's perfectly fine. We're an identity as a service provider, which basically means that we try to make it as easy as possible for anybody to implement a secure authentication flow so you can focus on building your actual products. I'm a Google developer expert, and I organize a few meetups, one in Belgium and also the Identity Security meetup in London. And if you want to find me on the internet, Sambigo is usually my username. So what I'm going to be talking about in this session today, I'm going to start off with some traditional authentication, or at least what I consider some traditional authentication. We're going to have a look at tokens and I'm going to try to explain what they are. And lastly, we're going to have a look at token-based authentication. So traditional authentication, in the most traditional scenario, you have a user who's using a browser to visit a website, and the browser is going to do requests to a backend, a server. And anytime the user clicks on a page, the browser is going to do the request and refresh the page and load that new page until the user goes to a web page that is protected, for which he or she needs to log in. So the user is going to enter their credentials, username, password most of the time. And through the browser, we're going to send it to the backend. If you have a user registered for these credentials and they're valid, then we're just going to return the page and the browser is going to render that page. And usually, because we don't want the user to log in with every new page request that we do, we also send a session cookie, and basically this session cookie is going to be sent with every subsequent request we do to a protected page or resource, just so that the user doesn't have to log in with every page, like I mentioned before. So what are the differences between a traditional web app like the one I just explained, where all the heavy lifting is done on the back end, and where we use a cookie-based approach, and single-page applications, the newer kind of applications on the web, which use a lot of JavaScript, often with these frameworks like Angular or React or Vue or whatever you want. A traditional architecture is usually the browser does the rendering and the backend does all of the logic. This can be a certain API, this can be a bunch of APIs, but most of the logic is happening on the API or on the backend, and the browser just renders stuff when it needs to render stuff. While a single-page architecture often can have a bunch of different services that do a certain thing, like giving some data from an API, some user-related data, maybe handle some payments. But the browser is going to do a bit more than just rendering content. It's also going to handle a lot of logic in JavaScript in the front end. And we often have an architecture, something like this. You might have a mobile app, a desktop app, a web app, a whole different array of apps, and they all need to authenticate with a certain API or APIs. But as we've seen in the example of the traditional web app, we use a cookie to remember if we're logged in or not. But cookies are something that is only used by the web. So it would be nice if we could just use a more or less similar way to remember authentication state for mobile, desktop, web, whatever kind of app you're using. So what are some of the problems with the traditional cookie-based approach? Cookies don't like CORS, and I assume anybody who's watching this session will agree with me, nobody likes CORS. If you run into a CORS problem, the first thing you do is you fire up Google, you type in, I have a CORS problem, and just read on Stack Overflow what the solution to your problem is. Just like us, cookies don't like CORS. A cookie that's been issued by another origin cannot be used by a different origin. Also, cookies require state, because inside of these cookies, most of the time we have a session ID, which is just a pointer to an ID in a database, which contains maybe some data about if the cookie or if the session itself is still valid, a date, an end date, an expiry date. And this means that we need to store this in our database. And cookies don't flow. You cannot pass a cookie from one backend to another backend, from one API to another API. So you'll have to create a bunch of cookies if you're using multiple APIs, which can be annoying. For example, if you want to do a request to your main API, but it needs some authentication or some account data, like your, I don't know, profile picture, you cannot just use a cookie generated by the first one on the second. So what's the solution? Maybe it's token-based authentication. We'll see in this session if we can use token-based authentication to solve some of these issues that I've just explained. But first, what is a cookie, or what is a token? I'm sorry. To me, a token is a unique identifier representing something. As long as you can take this token and get some meaning out of it, to me, that's a valid token. There are a bunch of different kinds of tokens. Maybe you've come across an access token before. And an access token is usually used with APIs to prove that you have access to do a certain action or to get certain data from that API. Maybe you've used an ID token before, and an ID token is usually used to handle identity-related information. When you log in through the OpenID Connect framework, for example, you can ask for an ID token, which will contain some more information about the person that's just authenticated. Maybe you've heard of refresh tokens. They're very powerful and they cause a lot of problems, especially with single-page applications. So I'm going to be talking about these a bit later. But basically what they allow you to do is they allow you to request a new access token if your previous access token has expired. And they're often in the form of an opaque string in the form of a UUID. This means that in itself, this token doesn't have any meaning, but by looking up the UUID in your database, you might get some meaning like the expiry date. But it doesn't have to be just a string. It can also be something like XML if you're working with a SAML. These tokens, several tokens are always XML, or it could be a JSON Web Token. And like mentioned in the introduction, this is something that we're going to be focusing on today. At Aussie, we use them as much as possible, just because we like them. They're very powerful. And if you've never seen a JSON Web Token before, this is a JSON Web Token. And you might see that this token is made up out of 3 different parts: the top part in red, the middle body in purple, and the bottom part in blue. And they are separated by the 2 dots in black. And this is something specific or typical about JSON Web Tokens. They will always contain these 3 parts with the 2 dots to separate them. So if you look at the first one, we see the part in red, and this one is called the header. And what this is basically just a base64 encoded JSON object. So if we would decode this base64, we can get something like this. And the header of a JSON Web Token will give you some more information about the token itself, the type. It's a JSON Web Token, obviously, because we're working with JSON Web Tokens, but also which algorithm we use to sign this token. We will see what a signature is later, but basically it tells us already, if you want to use this token, you have to know how to handle this algorithm, in this case, HS256. Then the second part and the most beefier part, the biggest part of a JSON Web Token is the payload. It's always the middle part. And again, this is some base64 encoded JSON. If you would decode this, you might see something like this. And what the payload is, it's a bunch of information that is useful to the person or service that is going to consume this token. If it's an ID token, it will contain some information about the identity. If it's an access token, it will contain some information about the API that it's meant to use with. And it can contain a bunch of things like subject, which is often the user ID, some information about the user, like a given name, family name, an issue date, and also something very powerful, it can contain an expiry date. So no need to save this somewhere in a database separately. A JSON Web Token can contain whether or not it's expired inside of the token, inside of the payload. So by just looking at this expiry date, the X part here at the bottom, we can already see if the token is still valid in terms of expiry date. And there's a bunch of different claims you can put in a payload. A claim is just a valid JSON key value pair. And the first one are reserved claims. These are just key value pairs that have been standardized by the JSON Web Token spec. Things like subject, issuer, issue date, and expiry date. There's a few others, but these are the most important ones, and they come from the JSON Web spec. The second type you have is public claims. And these are not really standardized by the JSON Web Token spec, but there is a whole list of public claims published on the IANA website, as you can see here, which contain a whole bunch of claims which are often used with APIs just for API interoperability. So if you create an API that issues JSON Web Tokens and I create one, we can all call a given name instead of a first name, just so you know what to expect. The same goes for family name. Some people might call it the last name, but if we agree that all of the JSON Web Token issuing APIs and consuming APIs are going to assume that it's family name, it makes it a bit more easier. And then the last name, or the last type of claims, is private claims. And this is basically any type of claim that is of use, that is useful to you. As long as it's valid JSON, you can put it in here. Keep in mind that this is just a base64 encoded JSON object, so never put something privacy sensitive or something important in here, like a credit card number, because everybody can just decode base64, like I said. Also, try to keep your payload as small as possible, because we're going to be sending this token with each request that we're going to do in the future, or at least each request to a protected endpoint. So the smaller the payload, the smaller the token is going to be in the end. Then lastly, this third part, the last part, is going to be our signature. And what is signature, basically what it is, it's basically you take your header, you take your payload, and you run it through a signing algorithm. There's a whole bunch of them. And this in this instance, we're going to use HMAX SHA-256 or whatever you pronounced it. So you take your header, you take your payload, and you take your secret, because this signing method works based on a shared secret. You run it, and in the end, you get a signature. This means that anytime something changes in your header or something changes in your payload, your signature will also change. This means that we can verify a JSON Web Token, because as soon as somebody tries to tamper with the content of the payload or the content of the header, the signature will not match anymore, and we can know that somebody tried to do something which we don't want them to do. Usually you use a better key than your super secret key, something random. So if we try this out, we have a JSON object, which is going to be our header. We take the base64 of that. Then we have a payload with some basic data. Take the base64 of this, and then run both of these through a signing algorithm that uses secret as the secret. and we just concatenate the 3 parts, we get a JSON Web Token. So if we copy this and go to JSONWebToken.io, I'll talk about this later a bit, but basically this contains a debugger that lets you debug JSON Web Tokens. And if you paste it in here, we'll see that we have our content. There's a space missing here because I did an oopsie, but we can see the content. And you can also see that the signature is invalid because we're assuming that our secret is going to be your 256-bit key. If we just change this to secret and paste it in again, our signature is verified because we used secret as our secret to sign this JSON Web Token. So real world examples, because talking about tokens, it's a bit abstract and we want to see the tokens, how we're going to use them in the real world. An access token, again, these are the tokens that we usually use to access a protected API resource or to do an action on a protected API endpoint. So they are going to contain some information useful to an API. Who issued the token, for example, the authorization server, which user we're dealing with, and which audience, which APIs can consume this token. If you are working with an API that's not in this audience array, you might want to reject that token. Issue that date, expiry date, and also the scopes. Which actions is this user allowed to do, and is it allowed to use this, this endpoint that it's trying to use at this moment? So this is all data concerning the use of APIs. An ID token will contain some information about the identity of the user. As we said before, it's going to be issued when a user is going to authenticate. So we can see some information about the identity, like the nickname, a picture maybe, and again, user ID, audience, whatever, issue that date and expiry date. So we always include the expiry date just so we can check if the token is still valid. And JSON Web Tokens are part of the HOSE specification. If you've never heard of this, it's basically a specification that specifies a few frameworks or a few things that are JSON and that help you do authentication and encryption on the web. And it stands for JSON Object Signing and Encryption. So we've seen JSON Web Token. There's also a JSON Web Key, JSON Web Signature, and JSON Web Encryption. These are all standards in this HOSE standards. Let's see what the question is. What's the best suggested way to use JSON Web Token in a protected way against XSS and CSRF? This is a bit of a longer question, so I'm going to try to answer this one at the end of the talk. Moving on. Up until now, we've seen a signature that's based on a secret, which is called a symmetrical algorithm, but you can also use asymmetrical algorithms. Like the ones here at the bottom, they all rely on a private key to create the signature and a public key to verify the signature. And if you want to use one of these algorithms, you want to be able to share the public key so people can verify the signatures based on that public key. We're going to use a JSON Web Key for this because that's one of the things we have in our tool belt in the HOSE specification. And it might look something like this. It basically is an array of public keys, and it contains some JSON which tells us all of the information we need to work with this public key. If you're using the OpenID specification, they are often exposed in this .well-known/OpenID configuration. If you look at it, it might look something like this. So it contains a bunch of public information about your authorization server. One of them is a JWTs URI. If you click on it, you can see that this is one of the public keys that is available to validate the JSON Web Tokens that I would be issuing. So you can share this with anybody that needs to know this. Since it's an asymmetrical algorithm, you can only validate keys with this public key. You cannot create a new key because you need a private key for that. And that private key, obviously, we're going to keep private. So .well-known/JWTs.json is often the place to find these public keys. So let's make a little comparison. On the right, you have a Belgian passport in 4 languages because we like to make it a bit more difficult. But what it says is I'm a passport issued by the Kingdom of Belgium, and I'm from the European Union. And basically, you can compare this to the header of a JSON Web Token because the passport on the front, it says what it is, and the header of a JSON Web Token also just mentions what it is. I'm a JSON Web Token, and you can use this algorithm to verify my signature. If you open the passport, you might see some information about myself, my picture, my name, my surname, the expiry date of the passport. And the same can be true for a JSON Web Token. If you look inside of the payload, you might find some information that's related to the identity if it's an ID token, and as well an expiry date. And then, of course, most passports have some ways of determining if it's a valid passport, yes or no, some UV marks or some fingerprint stuff or whatever. And the same is for a JSON Web Token. It has a signature that lets you validate the token, so you can be sure that nobody tried to attempt to change something in the payload or the header. So basically, a JSON Web Token is a passport on the web. So let's see one in action. So I have this little web app here in front of me, and it has two buttons, one to show you dog pictures. And every time I click on it, I get a random dog picture, which is nice. It also has another button that will do the same for cats, but anybody who knows or who owns a cat knows that cats are a bit more difficult to work with than dogs. So to show you cat pictures, you need to be authenticated. If you click on the login button and we authenticate with Google, just because it's easy, we now authenticated successfully, and a few things that have happened. The first thing we can see is that we now have my username and my picture already displayed on the right top side. This is because when we authenticated and our authentication was successful, we issued an ID token, which contains the information about the identity of the person that authenticated successfully, and we can then use that ID token and show the data inside of that token. But we didn't only issue an ID token, we also issued an access token, so we can show cat pictures. So now with every request to our backend, to our API for a cat picture, we're going to send along the access token as well. If you look at this from an API perspective, we have, in a very simplified version, we have an authorization or authentication endpoint. And if we run this, oops, I'm sorry, I clicked the stop sharing button instead of the, so let's try that again. Let me move this. If we click this and the username and password are correct, we will be issued a JSON Web Token. Let's copy this for later. If we want to request a new dog picture, we just click on it, and since the dog picture endpoint is public, we can just request dog pictures as many as we want. And then if we want to get a cat picture, we'll see that once we try to request it, we get an error stating no authorization token was found. So we'll have to send it along as a bearer token. And if I paste in the one we just requested, it should work. And it does, we can request cat pictures. But like I said, JSON Web Tokens, they already contain some information inside of them concerning the validity, if they are expired or not, for example. And they also have the signature that determines if somebody tried to tamper with them. So if you would copy an expired JSON Web Token and try to pass that one without doing any extra request, as soon as we try to use this one, we're going to look inside of the token and see that the JSON Web Token is not valid anymore because the expiry date is in the past. And the same goes for a JSON Web Token, of which the signature doesn't match the content of the payload and the header. So once we try to use one of those tokens, we can see that it's an invalid signature and we will not accept it as well. So without doing any extra requests, we were able to reject tokens based on the expiry date, based on the signature. You could also reject them based on scopes, for example, if your user is not allowed to access certain endpoints and some other things. If you want to know more, JSONWebToken.io, which is the website I showed earlier, which contains this debugger. It's built and maintained by Auth0, just as a disclaimer, and we do not do anything with them. We don't send them to a backend. It's all done on the front end, so you can safely paste your JSON Web Tokens, and we're not some pyramid scheme that tries to steal your tokens. It also contains a bunch of libraries in a lot of different languages, just so it can make your life a bit easier working with JSON Web Tokens, and you don't have to do all of the validation logic yourself. There's also JSON Web Token Handbook. It's an ebook which we wrote, and it goes very in depth into everything JSON Web Token. If you really want to know all the dirty secrets and all the dirty details, I suggest you read this. It's very interesting if you want to know it all, but this goes beyond the basic usage of JSON Web Tokens. So are there some downsides to JSON Web Tokens? Of course, there's a downside to anything. Invalidation of token is a bit harder because a JSON Web Token contains all of the information inside of it. It contains expiry date, it contains scopes or whatever. As soon as you issue a JSON Web Token, it's out there, it's valid until the token becomes invalid. So if you want to revoke one, it becomes a bit harder. This is usually done with a blacklist or a whitelist. So you're going to check that black or whitelist first before you're going to validate the token, which is a bit more annoying if you want to do that. Also, if you leak your secret or your private keys, that can be a headache because that means that everybody can just create JSON Web Tokens for your API or your services, and we don't want that. That's why it's called secrets and private keys. We want to keep them very secure somewhere where we know that they're safe. And again, don't put any sensitive data in a JSON Web Token because it's just base64. And we can go to base64encoder.com or whatever website exists and paste it in there and see what's in the JSON Web Tokens. So we've seen what a JSON Web Token is. Let's see how we can use them with a token-based approach and with single-based applications. So again, the same example as in the beginning: user, browser, backend, API, whatever you have. The user just requests pages until it hits a protected API endpoint, and it's going to try to authenticate with its username, password, its credentials. If they match, we're going to send back an access token. And instead of a cookie, which we saw in the beginning, we're going to send back an access token stored somewhere in memory. And every time we want to request a protected API endpoint after that, we're going to send along the access token to prove that we have access to that API endpoint. And once we have access, we can just get back all the data we need. In JSON or in JavaScript, it can look something like this. And the important part is that you set the authorization header to bearer and then your JSON Web Token, just so your API can find the token and see if it's valid for that API or not. And there's a few frameworks that deal with token-based authentication on the web. The most famous one is OAuth. And if you look at the definition of OAuth, OAuth 2.0 is a protocol that allows a user to grant limited access to their resources. And that's the most important part of the specification. It allows you to grant limited access to their resources, which means that you can grant access to certain parts of an API instead of the whole parts, instead of the whole API. And the other important part of this is that it's used to grant access, but it's not used to authenticate. It's not used, or it should not be used to handle identity. So for example, if you want to import Gmail contacts into your application, you're going to use auth to access Gmail. Can I please get access to the contacts of this user? And can I please just copy them to my application? But you're not going to request access to Gmail itself or to the identity of your Gmail user, just your contacts in this example. And the other side is OpenID Connect, which by its definition, OpenID Connect was created as an identity layer for Auth 2.0. So if we take everything from Auth, everything that's specified, and just add an identity layer on top of that, we have OpenID Connect, rather. And this you can use, for example, log in with Google, because when you log in with Google, you're going to ask some information about the identity of your Google user. And you're not going to ask, can I please copy all of your contacts? You just want some identity related information. You could ask for more information, like copying the contacts as well. OpenID Connect can do that since it's just a layer on top of Auth. So it has everything that Auth can do and then some. If you look at this in an example, I split my authorization server from the rest of my API just because it's easier to explain like this. So when a user wants to log in, we send the credentials to our authorization server. And if they're valid, we send back the access token, and we can also send back an ID token. And if you really want to, a refresh token as well. And we save them somewhere in memory. And every time we want to do a request to our API, which is to a protected API endpoint, we're going to send along the access token, and we might use the ID token to show some identity-related information on our web app. And if the token is valid, you get your data back. But I've mentioned before a few times that we save them in memory, and I deliberately say in memory and not somewhere in local storage or in IndexedDB or whatever, because if you store them somewhere persistently, they become a target or become very vulnerable for XSS attacks, and we don't want that. So if we store them somewhere in memory, this means that the user has to log in with every visit, because the tokens will be gone as soon as the user refreshes your page, or if it goes away from your web app and it comes back at a later point. It doesn't mean that the beginning of the login flow remains the same as in the previous example. We get our tokens back, our access token or ID token, and very maybe your refresh token. And together with those, our authorization server will also issue a session cookie. And then with each next visit, we will just send the session cookie first to authorization server. If the session inside of that cookie is still valid, the authorization server will return the tokens we need, and we can do the rest of our business that we want to do with all of the tokens. So we're going to save this cookie, or the browser is going to save this cookie. And as soon as you bootstrap your single page application, you're going to send this to your authorization server, often in an iframe in the background. It's called a silent request. And if the session is still valid in that cookie, you get your tokens, which means that you fetch new tokens with each refresh or with each new visit, which also means that you can rotate your tokens, that you can issue new tokens with each new visit, which makes it a bit more secure. And you don't have to store your tokens somewhere persistently, like local storage or session storage or IndexedDB. So they are less vulnerable for XSS attacks. And then you can use your tokens. This example used the auth implicit flow, which is the most used auth flow for single page applications. But there's a few things that are not so great about this flow. They have insufficient redirect URI validation. They can leak credentials by the referrer header. They might expose your tokens or your access token in the browser history, and they might be vulnerable for token injection. Most of these have been solved by some workarounds, like the insufficient redirect URI validation. You can enforce a strict match between the redirect URI requested at runtime and the one previously registered, because usually when you want to work with Auth or OpenID Connect, you're going to register a client which lives on a certain URI. So only clients from that URI can fetch tokens or can request new tokens. Credential leakage can be solved by the referrer policy header, and the browser history. Leaking your tokens in your browser history can also be solved most of the time by using the form post response mode. That's not always possible with single page applications, but you might be able to solve it with it. But because of these vulnerabilities, the IETF, which is the Internet Engineering Task Force, published a new best practices document stating that you should try to avoid the implicit flow and go to a new flow called the authorization code with proof key for code exchange. PKCE very short flow, which is a bit more complicated, but solves most or all of these issues that the implicit flow has. If you want to read more about the whys of why the IETF advises to use a PKCE flow, you can find it in this URL or at this blog post that we wrote, which explains what's wrong with the implicit flow in a very readable way. So if we look at the PKCE flow for a minute, our example, the setup is still the same. We have our browser, we have our two APIs, one for authorization and authentication, and the other one for just all the regular other stuff. But when we send or when we redirect to our authorization server to enter the user credentials, username and password, we're not only going to do the redirect and let the user enter the credentials on that page, we're also going to send a code challenge to that page. And once the user has entered their credentials, it's going to send us back a code, which we then can use to create a code verifier, and we send the code back with the code verifier to authorization server. So together with this first code challenge, this code and the code verifier, our authorization server can be sure that it was the same client that initiated the request that is going to receive the tokens in the end. So a little note about access tokens as JSON Web Tokens. OAuth and OpenID Connect do not specify what format an access token should be. They do not have to be JSON Web Tokens. They can be anything. A lot of people just use opaque UID strings as access tokens, and that's perfectly fine. There is, however, an IETF draft to standardize the way you can use JSON Web Tokens as access tokens. And if you would look at that, it would look a bit similar like the ones I showed before. The type will be access token plus JSON Web Token, and it basically tries to standardize all of the content inside of the payload. So if you want to use JSON Web Tokens as an access token, it might be good to look at this standard or this draft for a standard, because it might become a thing in the future. If, however, you're working with ID tokens, they're always going to be a JSON Web Token, because the OpenID Connect spec specifies that an ID token is going to be a JSON Web Token, mainly because it contains some information about the identity. So we want to have a form of token that can contain a payload like a JSON Web Token. And then a note about refresh tokens and single page applications. A refresh token allows you to request a new access token if your access token is expired. And this is something very powerful. But because single page applications handle a lot of logic on the front end, they become a bit more vulnerable to attacks, XSS attacks and whatever. So if a refresh token would get stolen, that would be dramatic. And the chances of them getting stolen are a bit higher with single page applications compared to other kinds of applications. So if you want to use refresh tokens in the front end, you should try to avoid it unless a system of refresh token rotation or sender constraints is in place. And what this means is, unless you rotate your refresh tokens every time you use your refresh token, you're going to issue a new token, or maybe you can do this also on a time-based approach. Or if you can do sender constraint, which is something theoretically possible, but there's no real way of doing this yet. Some people are thinking about how to do this. This means that you can tie a token to a sender and a receiver, or to a sender mostly. That's not really possible yet. Refresh token rotation is possible, but my advice would be to avoid using refresh tokens in the front end and use a way like this silent request I showed earlier to fetch new tokens on every refresh or every new revisit. So does this approach solve for CORS? You can wonder yourself if you think this approach solves for CORS. And my answer to that question would be yeah, because a token is not issued based on an origin. A token that's been issued by a certain server can be used by another server, other origin, other domain, as long as the other party also knows how to validate that token. So if it has access to the public key or the shared secret, it can validate the signature and can look inside of the token and determine if it's still valid. The same thing goes for flow. You can pass along tokens from one server to the other. This is usually not done. You're usually going to exchange it with a token endpoint for a new token. But in theory, you can just pass along tokens from API to API as long as all of your APIs know how to validate that token. And does this approach solve keeping state? In theory, it does solve that problem because a JSON Web Token contains all of the information you need to verify the token. But if you want to do some more things like keeping a blacklist or a whitelist of invalidated tokens, or if you want to do the silent approach for which you're going to issue a session cookie anyway, you might have to keep some state after all. So let's summarize. Using session cookies is hard with single page applications, mostly because we work with different origins. We often have multiple API endpoints. We might have some external APIs as well. And this gives us some CORS issues, flow issues, and we might have to keep some state, which we've seen just now that you might also have to do with JSON Web Tokens. But anyway, it's a bit harder. Status authentication is possible if you're not doing a blacklist or whitelist or the silent request approach. And JSON Web Tokens consist out of 3 parts: the header, which contains some information about the token itself; the payload, which contains all of the other information that your API or service is going to need in order to work with this token; and the signature, which lets you verify the content of that header and that payload. If you want to know more, JSONWebToken.io, the blog post I mentioned before, and our blog is full of other interesting material as well. If you want to find these slides again, jsonwebtoken.sambigo.tech, but there will be, this link will also be shared later. That being said, thank you. And if you have any questions, I will try to answer them. And there was one before. What's the best suggested way to use JSON Web Tokens in a protected way against XSS and CSRF attacks? So the answer to that is already mentioned in my session, I think. Don't store them somewhere persistently. This will protect you against XSS because you will not be able to steal them as easily as you are when they're stored on local storage or whatever. And CSRF is not really related to tokens. So that's not really something I can answer with. Are there any other questions?
So thanks for that, Sam. It was a great session, very, very useful. Hope everyone enjoyed it. If anyone does have any questions, you can feel free to post them into the live session channel now. Otherwise, we can collect them after the session. And just to let everybody know who's listening along, either via the website on YouTube or listening to the recording after, the links that you've seen during the session today, we will share into our Slack community. So the best way to access them is to become a member if you're already not part of the community. And as we come towards the end of the session, I just want to say, Sam, a huge thanks to you for taking us through today. And we hope it won't be the last time that you join us for a live session. We'll see you again, hopefully in the new year. And to everyone listening, just to let you know that we have one more virtual session lined up for this year. As we say hi to Sam's cat that we can see making a guest appearance on screen, which is always awesome. We have one more session, which is on the 19th of December, and it'll actually be a panel discussion on practical DevSecOps. We have a great lineup of people on our panel, so you can check out our website, mydevsecops.io, for all the details on who will be part of that particular session. And in the meantime, Sam, thanks once again for joining us today. If everyone, if you enjoyed this session, if you know people who think you would benefit from listening along today, please share the recording amongst your networks. The recording will be up on the website in just a short while. And with that said, we can close the session today. So thanks again, Sam. Thanks everyone who's listening for your time. I will see you again next time. Thanks everyone.